So space, or as I'm calling it, new space. Well, why is it new space? Well, we're looking for a sustainable way to have a business that fundamentally uses space as its foundation. So we've had missions, we've had discovery, we've had the testing of science, scientific theory, and now we're looking for communications. We've got satellite communications, of course, we've got other satellite images, other things. But what will be profitable, sustainable businesses? And I'm defining a sustainable business as a profitable business. There is a return on capital. So that is by nature a private industry. So what makes for a viable business when we use space as the essential target for that business? Well, we've gone from, as I mentioned, missions and discovery. So, growing up and watching the moon mission, well, that was just a phenomenal engineering achievement, a phenomenal test of rocket science, and great discovery. But there wasn't a business model to that. There wasn't a commercial dimension to that, even though there have been some commercial side effects. But it's not sustainable because it needed government subsidy, government expenditure. It needed a lot of individual subsidies to make anything happen, and those missions happened quite irregularly. So how can we go from that to something that's economically sustainable? And there are business models, and one of the things we want to talk about is what does create a sustainable business model. So I talked about profitability, and what we're seeing is with various industries where communication and data are critical, and now we're discovering, well, every industry, communication and data is critical. So space can provide a platform and essentially an infrastructure that allows unprecedented access and perspective. And it also provides significant data. It provides a lot of data, which we'll talk about, but significant data. And let's use a couple of examples. One where we've got communications, right? So now we're able to have low orbiting satellites like Starlink, and we're able to have communications, which have become, among other things, critical to a place like Ukraine, which might not have infrastructure or their infrastructure is destroyed. But now we have effective communications with Starlink. Well, it's obviously stress tested, but that means that it can work on a global basis. And that enables very interesting business models that are earthbound. Earthbound when you look at data, communications, networking software, software management. These are all emerging businesses to handle this new form of data and communications. Other things for industry, and agriculture is a great example, where having a perspective that a satellite enables, you can see the use of land, you can see the effectiveness of agriculture, you can see new applications for agriculture that may be possible. You can do testing and verification that wouldn't otherwise be possible if you were just land-bound or terrestrial, right? And of course, the other thing, communications in and of itself, well, there's global satellite positioning, right? So we know where we are because of satellites. So space is an industry that enables location services, it enables guidance, communications, all these kinds of things. So we're seeing really the nascent form of sustainable business models. And what's happening now is there is a launch every other day of some satellite or some form of space creature, I'll call it. And to think about that, like every other day. So when we had our moon missions, et cetera, maybe we had a launch every 6 months. What seems to make the papers today is a launch maybe every 3 or 4 months. But what's happening, and we'll use SpaceX as an example, SpaceX launches about every 6 days. They launch something, right? And now we're having a launch every other day. We're pretty much going to get to a satellite launch or a launch of some communication device or some kind of space-based device every day. And that becomes an interesting global opportunity. Right? Now, what have we seen? Well, we've seen science, military, commercial applications. So science applications, well, we first saw those applications with the moonshots and other explorations. We're seeing it now with the cooperation of the International Space Station. But then we go from cooperation, which is that International Space Station and the spirit of discovery among nations, and then we go to a fragmentation where we've got China with their own version. We've got Russia now a pariah state and will probably remain a pariah state for some time. Now that cooperation is now fragmenting. So is there a solution? Well, there's very expensive subsidies on the government side, or there's competition, and competition is private industry. And if we lead to private industry and competition, well, private industry needs to be profitable. profitable in order to sustain a return on investment, which enables continued investment, continued business, right? So that is maybe the sweet spot of where we're heading. Of course, if we overshoot that, we get to the outright, military applications, which we can talk about, where you have antagonism instead of commercial opportunity. So we can destroy satellites, we can launch satellites, we can have data, networking, communications management. We can apply that to all sorts of industries, ranging from agriculture to communications to construction even. Or we can simply try to get in each other's way. Well, I'm not going to predict anything. Of course, I'm not the biggest fan of what human nature leads to, because usually we need a tragedy before we figure out that we've been doing something wrong, right? We're hardly preemptive in thinking about how to cooperate, and we're hardly preemptive in thinking about how the long-term impact of what we're doing. We're launching debris into space. We have fuel that we're expending. We have all these things that create danger, create issues, create vulnerabilities. We're not going to address them, but they exist, right? So yes, there's a great opportunity. Yes, new space is something that is a frontier for very interesting creations of value, but also a frontier for antagonism and difficulty. So as we think about this, we go from, I say, Sputnik to tourism, right? The Sputnik launch, of course, was the shot heard around the world. If you're in the science community, okay, rocket science works. We can launch things into space. We can launch things and ultimately have an orbiting satellite. Well, that led to the space race and all those things, but that led to discovery. It led to innovation. And a sideshow, of course, is this tourism. We don't really care about somebody paying several $100,000 to have a seat in something that's a low orbiting vehicle, right? But what we do care about are businesses that can lead to communications and information. And so we have data and data applications that are possible. We talk about agriculture, we talk about finance, the most important industries in the world, not really can be disrupted so much as augmented with significant bits of information. You want to invest in a retail operation, well, you can now get pictures of every one of their parking lots to see if people are actually going and shopping there. You can see trails of communication. You can see agricultural efforts. You can then see how the world is changing, how the environment is changing. There are applications there, of course. There's many, many broad applications. And so to get a sense of the scope that I'm talking about, right now, there are about 7,000 satellites orbiting Earth. About 4,000 of those belong to SpaceX, right? So one company, there's a lot of Starlink satellites that are low orbiting satellites that are very small, right? But by 2030, it can be possible to have 10 million, that's right, 10 million satellites orbiting Earth. Now, my colleagues at MIT tell me that they can manage that safely, or one can manage this. If you do it right? So the astrophysicists step in and say, if we actually manage the way these satellites are launched and how they orbit, the Earth can actually manage 10 million orbiting satellites. It seems extraordinary to me, but I'm taking that at face value. But assuming there's not as much cooperation, which I think is a reasonable assumption, assuming that there'll be challenges and other issues, but that still means it's beyond an order of magnitude. It could be 1 million or more orbiting satellites in about 7 years. That's extraordinary. So what happens? Well, we've just created a commons, as it were, right? So space is our common ground. And from economics, right, the tragedy of the commons, right? So if people start abusing their position, if they start taking advantage of maybe a slight edge, well, everyone else is going to do that too. So ultimately, what could be a very cooperative and potentially very profitable overall platform can become the tragedy of the commons. There can be inefficiency, there can be difficulties, there can be satellites that are destroyed, there can be space junk that we've talked about. There's lots of issues that create the other side of this opportunity, which it might lead to more antagonism and more challenges, right? So the positive side here is we have an incredible structure for systems and infrastructure. Now, the distance to satellites create latency. We can't overcome physics, regardless of your entrepreneurial zeal. Those waves only move at, such a speed, and they're only formed in such a way, and you can only have communications at such a speed. You can only have data at such a rate, right? So we can't overcome the physical limitations, but with 7,000 to 10 million satellites, we can end up with a lot of very interesting data communication systems, and real businesses will exist with the base stations, the information services, the databases that get gathered from all that information, right? It's almost too much to even envision, but all that data means we've got something that can really create economic sustainability, as I'm defining it. And right now, there are approximately 40 nations that have launched a satellite or much more. In about 7 or 8 years, we expect that number to be maybe a third of all nations. More than 60 countries will have some space program, some satellite venture going, right? So that's a third of the world. And this is a big business potential, right? So I called it, at the end of the day, when you have a lot of data, you have a lot of information you're gathering, it's a software problem. And that's an economic opportunity, understanding how to gain value from that software. And on Earth, we've got a lot of data. We call it big data. So with space, I'm calling it big data, right? You're going to get a lot of information. And it's not going to be as directed as maybe landlocked or terrestrial data is, right? So Amazon has data on your shopping, right? Well, satellite data is very different, right? So we have to figure out how to create value from that. That's a business. There are many business opportunities from understanding that this is a software problem after all, right? The rocket science has been figured out. It's a software problem. How do we manage it? How do we extract value? How do we understand how to manage it even better? It probably becomes an artificial intelligence issue. There's lots of things that we can manage and do. So those applications can be very valuable for all industries. Name every large industry. I've mentioned agriculture, I've mentioned communications, I've mentioned finance, transportation. We can get a shot of what's happening in any transportation system, how to modify that, how to understand it, how to learn from it. We have the machine learning and artificial intelligence tools to understand how to make sense of this data when it comes to air traffic, when it comes to terrestrial traffic, all of that, and many other applications. So this is a very exciting area. Of course, all of that is in a non-cooperative world, right? So we're becoming less and less cooperative. We will have the tragedy of the commons more and more, and these are issues that we're going to have to deal with. But there continues to be space as a platform for new economic opportunity, right? So now sustainability. Well, there's environmental sustainability. There's an understanding that we have transformational technologies, but let's not be starry-eyed, right? We have to be earthbound. These have to be businesses that are sustainable. But while we're at it, it would be a nice idea to try to be preemptive about ruining the planet a little bit further, right? So when the automobile came along, we thought, what a great invention. Nobody thought about what are the ramifications for all this manufacturing, all this transportation, all this burning of fossil fuels. Only now, when we're seeing real issues associated with that, do we have a sense, well, maybe we should be doing something about that, right? I mean, I remember in the 1970s in Los Angeles, there were, college baseball games that were smogged out. Literally, it was unhealthy to exercise outdoors. Well, we figured out we don't want to sustain that any longer, right? So we tried to find a way to get around that, but it was only when the tragedy hit. Unfortunately, I don't have the same kind of optimism that says, well, now that we've learned our lesson, let's be preemptive and let's think about all the fuel we're expending, all the junk we're tossing into space. What is really important for our planet and our cooperative nature together? That would be nice. It's not going to happen. We're going to wait for some tragedy before we do anything. I'm just going to say that, right? So the way to think about this now is how to have sustainable economic models that can work and function, and then maybe we can avoid this, right? So that's why I'm saying let's be earthbound. Let's not be starry-eyed. Let's figure out how to have practical solutions that are efficient use of resources, efficient use of data, perhaps making other industries more efficient, understanding weather, climate, other things more effectively. There are side effects that can be quite beneficial, right? But what it takes like anything. It takes entrepreneurship, it takes discovery, I call it unfettered capital, and independence, right? So the challenge here is space is something that has basically been controlled by government forever, essentially, right? We've morphed into ventures like SpaceX, but let's be clear, SpaceX is still subsidized by the government. Most of these guys are NASA systems. It's probably not a sustainable, profitable company the way it goes. I'll just be so bold as to say that. It's very overvalued. It's a private business. It's not profitable. I don't think it's ever going to be profitable, right? But it's paving the way, and there are ways it can maybe morph into a profitable company. and maybe Starlink ultimately becomes a profitable venture. But there's ways to think about this, that the vanguard tends to show where there's opportunity. And my argument here is they are showing there's opportunity with private capital that's unfettered, where entrepreneurs can create sustainable, profitable businesses. And that's the real opportunity here. So those models do exist, right? So in summary, there are viable businesses that can be created from space. Profitable, sustainable businesses. They're based on data, based on communications, based on understanding of how to model and network that information that's terrestrial as well as space-based. And so we've seen the example of, well, it's real science, and there's military applications, right? This gets very confusing, but there are commercial applications with commercial discipline, right? So let's ignore the tourism and that stuff as a sideshow. Systems, infrastructure, these kinds of things really matter. That information, that data, that big data will be valuable. Ways to apply that and use that and manage that via software, via communications networks. There are ways that can enable, proprietary research and knowledge and understanding, proprietary businesses, and profitability. And it is a software problem. The way to make money in space is not launching rockets, regardless of how cost effective those launches can be. That's great, that's an innovation, but that's not a sustainable, profitable business. A sustainable, profitable business is software management, software applications to industries on a global basis. That's a real opportunity, and those opportunities are developing. And there are real companies that are doing this. And so ultimately, that's true sustainability. And while we're at it, it would be a nice idea to think about how to be sustainable for our planet and our orbits around ourselves. We're probably not going to do that until there's a tragedy that needs to be dealt with. We deal with tragedy of the commons more than we deal with preemptive thought. That's who we are. But my punchline here is new space is a real business opportunity. It's a platform. It enables infrastructure. It enables the acquisition of data. That data can be managed, manipulated, understood. It's a software management problem. It's artificial intelligence and machine learning, applying very specific applications to global industries. And that's a real opportunity.